Okay, so for this project, you have to cut out. Well, okay, for the open box problem, I can do the closed box one next. You have to cut out 4 corners because it has to look like this, and you have to fold up these to make an open box. It's gonna look kind of like a tray or something like that. Um, and these lengths have to be equal, so that has to be equal to that, because in order for those to line up to make a box, they have to. That's going to be the height. It's going to be the height you use. So we can call that length x. That's what you're trying to find to maximize the volume of the box. So that's x all around. So the volume, to find a formula, the volume is length times width times height for volume. Your length. So right now the sheet you're using is 11 inches across on the bottom, and since you're cutting out this much into it, it's basically 11 minus 2 x's. So 11 minus 2x. That's going to be this length, because if you look, it's 11 minus 2x, because when you fold these up, it's going to be the length, this length of the box is going to be that, 11 minus 2x. That was always like something tricky with these box problems. Well, at least I thought. Same thing over here, same deal. You're gonna have this whole length minus 1x, 2x. So this whole length is 8.5. So 8.5 minus 2x. 8.5 minus 2x. That's the width. The height. So you figured out the width and the length. Length, width. The height is going to be this, which is x. That's how much you're cutting. So the height is always just going to be x all around, because you're cutting out the same length from each corner. So the height is x. So now we can substitute these values in that we know for the volume equation. So length 11 minus 2x, width 8.5 minus 2x, height is x. Now we FOIL that out. So you're going to get, let's see, I have it written down here. I just plugged it into a computer program because I was bored and didn't want to FOIL it out because I'm lazy. You're going to get 4x cubed minus 39x squared plus 93.5x. Now the maximum volume is equal to the, sorry, let me rephrase this. The zeros of the derivative are gonna lead you to the maximum volume. I don't know if you've gone over that in class, but all you have to do is find the derivative, set it equal to 0. This is kind of like a definition. The definition is like the zeros of the derivative is the x value of the maximum for the original function. That's a basic, it's kind of like a little definition you learn. I don't know if she's taught you that, but if you know that, she'll be impressed. Well, I mean, you should know that. You have to know that to do this project. So you take the derivative, which is, you know how to do this, 12x minus 78x plus 93.5. Set that equal to 0 to find the zeros. That's 93.5. I don't know if you can see. And then x is going to equal 1.5854197 and 4.91458203. Now we have 2 answers here. You have to figure out which one's wrong. To do that, well, this is how you do it. You basically need to think, all right, which length makes more sense with the situation we're using. Now, if you look, the length you're using, x, you're gonna cut it out from this side and from this side, and then like make squares. You can cut out 1.5 inches, 1.58 inches over here, and there would be, well, like 5.5 here, approximately. You can't cut out 4.9 from both sides. 4.9 in, 4.9 in, because 4.9 plus another 4.9, that's greater than 8.5. So I would be able to cut out 4.9 inches here, and it would actually probably go to like here, and that I wouldn't be able to cut out another 4.9 box over here. So that's an unreasonable answer. Make sure you explain that. Make sure you explain, like, it's like a domain. Your domain is x has to be between 0, greater than 0, and less than half of this length, because you have to fit 2 of these squares in. So half of that length, 4.25. That's the domain you have to follow. So that is not in your domain. So this is the x value that's going to give you the maximum volume. You're going to have to plug that back into the original. So this is the original formula. This is the derivative. You're going to have to plug it into the original, because the original is the volume with respect to x, which is the length you cut in. So you plug that back into your original, and you're going to get volume 1.58541797. Let's make it a function. It's equal to 66.14823499 inches cubed. And that's your answer. It's only for an 8.5 by 11 piece of paper. It's going to be completely different if you have a different size paper, and that's just for an open top box. Now, for a closed box, your cutting is going to look like this. It looks kind of weird, but it's actually not as complicated as you think, because I pull this all out, it makes a nice little box. Let's just pretend that it's all taped, like so. So, if you look here, we need to use x again, and we need to use everything in terms of x. We can't call this length y and this length x. You have to use it all in one variable so you can get the derivative without using implicit differentiation. So this is going to be x and x as well. Those have to be equal, because when you line them up, that has to be your height, and those have to be equal to make a nice box. Same down here. Same over here, because these heights have to be equal, just based on geometry. They have to be. I mean, that's how it's going to line up. So that means this is x2. Same reason. This is going to be x as well, because it has to fold up like that. They have to meet. And then this right here, and this length, we have to figure out these lengths. Oh, and these lengths. So we have to figure out this dimension, this dimension, this dimension, which is going to be the same as this dimension. Now we have to figure out this dimension, which is obviously the same as that. So this is the tricky part. You have to, well, first let's figure out this one. This dimension. Just like the other one, it's going to be, this is 8.5. This whole thing is 8.5 minus 2x. So that's 8.5 minus 2x. Now this length right here, we have to figure out. Because this is going to be the same as that, because when you fold up, I'm trying to get this in view. This is going to be the same as that, because when you fold up this little paper thing, those two line up. This lines up with that. If you watch again, they have to be equal. You have to kind of visualize this when you're like taking a test, or just with some practice, you'll be able to know it off the top of your head. Okay, so this whole length we know is 11. Now to find how many inches are within these lengths. So this is 11 minus 1x minus 2x, so 11 minus 1x here, 2x here, 11 minus 2x, and that's how long this is and that is together. But you want to just get one, so it's 11 minus 1x minus 2x, 11 minus 2x divided by 2. Because what you found is 11 minus 2x is only going to give you this length and that length. So you want to divide it by 2, so you get 2, so minus 2x divided by 2. That is going to be your width, or your length of the box, I guess, or width, whatever you want to call it. That can be width. Yeah, let's make that width. That can be width. This one can be length. And this one can be height, obviously. That'll be your width. So once again, volume is length times width times height. Volume length, we got 8.5 minus 2x. Width, we got 11 minus 2x divided by 2. That's 0. Yep. And then x is the height. FOIL that out. You get 2x cubed minus 19.5. This pen is running out of ink. 19.5 x squared plus 46.75 x. That's when you FOIL it out. Then, once again, the zeros of the derivative, that x value for the 0 is equal to the maximum or minimum, depending on your situation, maximum of the original. So you're going to take the derivative of this, which is, so v prime, or derivative, is going to equal 6x squared minus 39x plus 46.75. Set that equal to 0. This you can just plug it into the quadratic program if you have it. It's really simple. You get x equals 1.58541797 and 4.91458203. Now, we have two x values again, and they actually happen to be the same x values as we had before. It just works that way. I can't really explain it. I don't know why it ends up like that. But remember, we can't cut out this much on both sides, here and there. It just won't fit. So that we can rule out because the domain from 0 to x 4.25. So that's going to be x value. Plug that back into the original function. Let me get a better pen. And you're going to get, these pens are dying on me. Vmax is going to equal 33.074111749. And that is when x is equal to 1.585411797. That is for the closed box. Make sure you show all the steps when you're writing up the lab report. I'm pretty sure it's a lab for you guys. I remember it was a lab for us. Well, it was like a project, but like I made a lab report for it. Make sure you write out all the steps. The explanation of why the derivatives of why the 0 of the derivatives is equal to the minimum and maximum of the original. I'm not sure if she wants you to know why that happens. I mean, I remember when she explained that to us, she didn't really go over why, which, I mean, I was angered about. which I was bothered about because I always like to know why things happen in math. But if you write this all out, maybe type it up and write steps and like explain why with words, not just like writing steps like I did here. She'll give you a good grade, and it'll be good. So yeah, that's how you do it. I hope this video uploads right.